Good afternoon, everybody. Can you hear me? Okay, there it is. Okay, I'm Jörg Fell. I'm CTO with HydrogenPro, and it's good to be back here in Hanover. It's the third time in a row we exhibit here, and we have seen a tremendous development in the hydrogen market, and it has been a tremendous development also for our company. We have been recently selected as supplier for the two largest hydrogen projects under development now in Europe. The takeaways from my presentation is the following. High-pressure alkaline electrolysis is the technology of choice for large-scale hydrogen production. It's a proven technology, and it's suitable for variable loads, typically associated with renewable energies. So, who are we and what do we offer? HydrogenPro is a company with headquarters in Norway, and we have offices in France. And with our experienced team, we supply turnkey hydrogen plants based on the state-of-the-art high-pressure technology which we received from our partner THE, co-exhibiting with us here at the fair. We work with selected sub-suppliers also from Germany and Belgium. And our partner THE is a well-renowned electrolyser manufacturer, one of the big players in the global electrolyser market. And they have last year installed China's largest electrolyser installation ever. It's a 20 megawatt plant equivalent to 4,400 normal cubic meter per hour. The main advantage of this technology is, first of all, the units are the largest capacities you will find on the market. The biggest ones supplying 1,000 normal cubic meter, that's almost 5 megawatt per unit. They're pressurized, so we can offer typically 30 bar pressure, both for the hydrogen and the oxygen side, and that makes the plant very versatile, and we can omit compressors in many applications. And with many years of experience, THE is on the road since 1994. With this experience, we have a reliable and very safe solution. The units are long-lived, and the investment costs are relatively low, very competitive, and the energy consumption, and that's what's count, is also low. So this translates in total to a very favorable total cost of hydrogen production. And what we can see is we can compete with fossil feedstocks. So that's extremely interesting in the grand picture of renewable energy transition. And the beauty of this system is it's a modular system. So we can easily upscale to large plants of typically 100 megawatt. And that's important for our customers. And that's why we were chosen also in the French projects. So that's the project. It's a gas-to-power project in Dunkirk. And it's managed by H2V, also exhibiting here at the fair. And they are also developing a gas-to-industry project in Le Havre, where we also have been chosen as a supplier. Further down the road, we will be looking at more energy-effective electrodes, making our systems even more competitive. Thank you. And if you have questions, we are at booth E46.
Thank you. If you could hand the microphone back to the sound technician, that would be great. He'll be collecting them up for the next guest. Up next on the stage is Bjørn Simonsen, VP Market Development and PR at Nel Hydrogen. Bjørn, welcome back.
Thank you. All right. Some of you know my company, some of you don't. We have a history which actually dates almost 100 years back. In 1927, we were part of Norsk Hydro, and we were part of quite a bit of an adventure because at that time, some of the biggest electrolyzer plants that have ever been built in history was being built in Norway. More than 300 megawatts altogether, being built for green ammonia. And a lot of you have probably heard about green ammonia during the last couple of years. Well, it's kind of exciting that it's coming back. So we have a technology that's been around for some time. Today, though, we are a pure play hydrogen technology company. We're listed on the Oslo Stock Exchange. We have a lot of enthusiastic shareholders, and we have our corporate office in Norway. We have a manufacturing in Norway, Denmark, and the US. Since 1927, we have manufactured quite a lot of electrolyzers, 3,500 plus altogether, and delivered them to pretty much all countries in the world with a name you can spell. We also make fueling stations. That's a little bit of a younger technology, but that has also been deployed quite widely now, introducing it into South Korea this year. Some will talk about alkaline, others will talk about PEM. We have both technologies, so we're typically not pushing one or the other. There is a market for both technologies today. We see a market for both technologies down the road, and that's why we have both today, both small and large. This is how it looks like at our facilities. We have our PEM manufacturing plant in the US, in Wallingford, just north of New York. More than 2,700 PEM systems delivered commercially in the market. And today we have a production capacity of roughly 40 megawatt per year. In Norway, we are manufacturing our alkaline electrolyzers, around about 800 systems delivered. We have today about 40 megawatt capacity per year, but are expanding that to 360 megawatt per year by 2020. I'll come back to that. And also, this is an electrolyzer pitch, but I also have to mention our facility in Denmark, which we just opened last September. So there we have industrialized production of hydrogen stations, and at full capacity we will be able to put 300 stations out of that facility per year. Those of you who know the market today know that these are quite kind of ambitious numbers, but we want to be ready for when this hits, because then it will get fast, it will get big very fast. This is the reason why we're scaling up our facility in Notodden to 360 megawatt per year. We are going to deliver 1,000 megawatt of alkaline electrolyzers to Nikola Motors over the course of 5 years very soon. So we need that capacity to deliver to them. And this is just for the first Nikola stations. That's going to be a lot bigger. And it's not just Nikola Motors. Those of you who are involved in the industry see that things are moving. People are talking gigawatts. And of course, if we're going to deliver electrolyzers to green ammonia, for example, one green ammonia plant will need more than 1 gigawatt of electrolysis. And sometime later down the road, when we go into steel, one steel plant will need more than 1 gigawatt of electrolysis. So the whole of industry will need to go through a transition to a much bigger scale. Of course, hopefully getting some sound economics on the way to that. But this also pushes down the price. The manufacturing price drops quite significantly when we do this, and that enables even a bigger market for all of us. And in the meantime, on the way to green ammonia and green steel, we will continue to deliver electrolyzers to the market we have today, to the food industry, the glass industry, polysilicon, chemical, mobility, chemical industry, and so forth. So it's quite a fun journey, and looking forward to interesting conversations with those of you who are interested. We're just over at the B70 across the road here. Thank you.
Thank you. Up next on the stage is Dr. Frank Allebrod, who's head of R&D at HTech Systems. Welcome, Frank.
Hello? Mic on? Oh, okay. Thanks a lot for the kind introduction, and welcome to the presentation of HTech Systems. HTech Systems is a company that supplies energy converters in the form of PEM electrolysis systems only. HTech Systems has stacks and systems in the product portfolio, ranging from the 1 kilowatt, 5 kilowatt range for the S-Series S30 up to the megawatt scale PEM electrolysis systems. We also see the growing markets. It's not only the storage of electrical energy in the form of hydrogen and the reconversion into electricity. There is also a huge demand of hydrogen in the industry. It is methanization, it's ammonia production. It's so versatile. There's a lot of hydrogen demand in the research and development. The markets are huge. I will come back to that later. To keep on track, to be first place in our technology, we work together with strong laboratories here in Germany. Fraunhofer ISE, Forschungszentrum Jülich, Fraunhofer IFAM, DLR, ZAE, ZBT are just a few of them, just to be mentioned. On the bottom, I showed a timeline of HTech Systems. There are few important dates. In 2010, GP Joule, a strong company for renewable energy, took over the lead at HTech Systems. And since then, things were going pretty fast. We had a proof of market phase in between 2011 and 2016. And actually, last year, we could sell our first products. We had to move into other offices also to increase our production capacity. We have a new office close to Hamburg to develop and produce PEM electrolysis stacks, and systems development and production is in Augsburg in the south of Germany. On this trade fair in Hanover, we are proud to announce also the megawatt scale electrolysis systems. We have a 1.4 megawatt electrolyzer now in our product portfolio. One thing that is not mentioned here, but which will be another important step for HTech Systems, is that last week we could announce that MAN, a very strong supplier of engines with more than 14,000 employees, took over 40% of HTech Systems. And so with that, we are now able also to scale up our production line. We have a strong partner with a lot of experience in mass production, and we will also put this into our products. To go a little bit more in detail for our electrolysis stacks and systems, on the right-hand side, you can see our Series S30 from 1 kilowatt to 5 kilowatt. It's just a very neat and compact design. It is not bigger than the size of a standard US orange juice box. We also have the system, the ME100 350, which produces 100 kilogram of hydrogen per day with a maximum power of 350 kilowatt. And as I mentioned before, our new product, the ME450 1400, with 1 megawatt weighted power and a production capacity of 450 kilograms of hydrogen per day. We have a new project ongoing. The first electrolyzers for this project will be installed this year. It is in the north of Germany. It's a very unique project where we have all the value chain, the entire value chain of hydrogen production, storage, and also distribution in just one place. We will build up 5 electrolysis systems, fueling stations, a bus transport for public, and as well the hydrogen production just in one region. And gives to the people a clear sign. The wind energy converters, they don't produce electricity only for the southern regions or for the entire region. You have a value gain just on stage. You have very clean transportation, noiseless transportation. You have jobs created, and this shows what the hydrogen community will supply in the future. A big value chain, not only clean production of energy, but also noiseless production of energy and transportation. This actually shows the production of wind energy that could not be produced in Germany. So in the last years, wind energy with almost 3 terawatt hours could not be produced because the grid is too small. So the wind energy converters, they had to be switched off. Anyway, the wind farmers had to be compensated for that, and so they had to be paid with 300 million euros. At the same time, we have a hydrogen demand in Germany of 70 terawatt hours. This means if we increase the overcapacity from wind energy converter by 20 times and transform it all into hydrogen, we still would find a customer to have this green hydrogen. We would not produce it for any of the new markets that are just arising. to come to the arising markets, I show you this study also from ENDWEDE, and it shows how much energy, renewable energy we will need in Germany until 2050 to reduce our carbon footprint by 95%. So it means until 2050 we have to supply 500 gigawatts of renewable energy. To store it and to make everything reliable, we have to produce at the same time 200 gigawatts of electrolysis. So this is a huge number, and we did a small calculation. We took our small stack, what I showed you, which has the size of an orange juice box, and wanted to see how many of them do we need to produce. And we came to the number of slightly above 5,000 units each day. So this is really huge. We can't do this at the moment, so we have to scale up. And it seems like, how should we do it? Is this possible? And of course it is. If you do another calculation, for each inhabitant of Germany, we need just 0.5 electrolyzers of this size until 2050. So we have more than 30 years of time to get every second inhabitant of an industrial country an electrolysis stack at the size of an orange juice box. This is really possible, and there are huge markets. We have a lot to learn, but yeah, we will take this challenge, and by that we will be carbon emission free. Thanks a lot for your attention, and see you on booth B52.
Thanks very much, Frank. Up next on the stage, Hector Maza, who is VP Business Development at Jenner.
Thank you.
ELX. Welcome, Hector.
Very much. Hello, everyone. Thanks a lot for the introduction. I guess I don't have to make the case anymore for the need that we have for large hydrogen systems. I think my colleagues here have done it for me very, very well. So I'm going to run very quickly through a little bit of who Giner is and what are we bringing to the party. So let me just make sure it's this. Oh, here it is. Sorry. So Giner has been around for about 46 years, and we are everything about PEM. PEM research and development throughout the many years allow us to understand very well what are the limits, and we haven't really found all the limits which we're still searching for. We do spin-offs of companies once those products become mature, and of course the electrolyzer side of the PEM systems is very, very mature. It's getting into maturity now. So there's other parts of Giner that I don't have enough time to talk about it, but I can host you at our booth in C47, and we'll likely talk about everything you want in PEM. These are just some of the projects and actually collaborators we have had through the years. We started out of GE, and we move on with a long collaboration with General Motors. We've had until now about 20 years working together with them in fuel cell and electrolysis development. They are more focused on the fuel cell side of the business, obviously. We would like to scale up everything else on the electrolyzer side. We have long collaboration with NASA, NIH, Department of Energy, Department of Defense. All those have been great contributors for us throughout the years, and then we bring these very high-end applications into a low-cost opportunities to bring into market with the industrial world. This is 101 electrolysis, but that's what it looks like on our side. 1 megawatt electrolyzer is the first platform out of a 2 megawatt platform that we have developed, and now we can grow that in the next three or 4 years for a 5 megawatt to 10 megawatt platform. Why are we going so big? We do everything at differential pressure, millisecond response times. Well, I think my friends already made the point for us, which is we have to go that big. It's not an option. So at the end of the day, all we have to do is scale up manufacturing because electrochemistry scales pretty well. These are just some of the systems we've done throughout the years, and you can see everything from high pressure, low pressure, very lightweight stacks for aerospace, and of course nuclear submarine application as well is some of the things we've done in the last many years, 2 decades and going. This is, of course, we don't have that many nuclear submarines, so we have to move on to more industrialized systems. We've done over 20,000 systems so far, and we're moving on to 30,000 over the last 2 decades. This is what the latest system that we delivered in California looks like. This is basically a 200 kilogram a day refueling station in Sonoma County, and everybody who wants to go taste some wine, we'll invite you to the last opening of that one. Moving along, we have had throughout the last 10 years, starting with Corsica, back in the day with collaboration with some of the companies that now became, we call it customer competitor. We buy from them, they buy from us. We collaborate together in some of the projects. That's on the upper left side. And then the newest one we're developing in the next 9 months or so, which is going to prove the lowest cost of a molecule of hydrogen ever done before. It's up here in the Netherlands, not too far from where we stand. These are just some of the projects we've done over the last few months and maybe a year or so. We have, of course, following H2 at scale, which is very well known these days. Everybody's trying to bring hydrogen at real scale. This is how they apply in all those terminologies. We've collaborated, of course, throughout the years to make our roadmap consistent with what's out available in the market in terms of projects. So we go from some kilowatts, or essentially 100 kilograms a day, to then 1 ton a day, to eventually 2.5 to 5 tons a day. That's the roadmap today. And this is how we compare, of course, with batteries. I was 2 weeks ago at the battery show, and everybody's just going nuts about batteries, but few people stop to think about what does it take to store energy and actually use it for extended period of time. If you're going to go more than 8 hours, it's really nonsense to go with batteries. You have to go to hydrogen. It's just you add more tanks. You don't have to replicate lithium ion over and over again. This is what a megawatt stack looks like. This one is in NREL today being tested. We have tested over 10,000 hours at our location, and we're doing it in third parties as well. Before we actually are able to launch a platform, we don't make models. We actually test it for tens of thousands of hours. This is what's happening. Everybody knows about solar, where it's going. Solar and wind are now reaching levelized cost of a kilowatt hour down into the 2 cents and 1.5 cents. What does that do to all of us in electrolysis is makes it available, makes it real. This is a little bit more about the Hydro project. I can talk about it later in our booth if you want to join us at C47. But essentially what we're doing here is we're going from wind straight into the molecule, straight to the pipeline. We're avoiding a lot of the losses in between, a lot of the losses of conversion from AC to DC, DC to AC. We are also putting it in a best vehicle to get to the end customer, which is a pipeline, not truck it with a very difficult logistics involved. We've also done tremendous efforts on the cost reduction side. Why? Because PEM is expensive. That's what everybody knows. Well, today is not the case anymore. It used to be 10 years ago. What we have now is we can bring the cost of the molecule down by reducing CapEx on one side, but also reducing the OpEx side of the equation. How so? We reduced about 90% of the cost of the CapEx in the last 12 to 15 years, and we are now moving on to roll. We actually have the capability of producing what used to be 2 weeks worth of electrolysis in about 2 hours. So now we can produce more electrolyzers that we actually can build. That's a good problem to have, especially when we hear what's coming down the pike for steel, for ammonia, green ammonia, which everybody would love to be collaborating. And I think my colleagues there have the right idea. And we've been in touch with both of those sectors very, very deeply. Sometimes people like to talk too much about mobility. I think that people are missing the point. Mobility is not the end game. It's all the other industries combined that we're still living in a methane world and a methane cracking, basically, or methane reforming world. So to conclude, I just want to say where we're headed in the future. Obviously, we have to scale up. So for the first time ever, we're actually investing not only with our money, but with other people's money to grow the facilities, to grow to 50 and 100 megawatts in the US capability. And later, we'll do that in Europe as well to maybe 200 and more, because that's what it's needed. Otherwise, we are not going to be a player. And we consistently have been a player, although this industry has always promised, overpromised, and maybe underdelivered. This is the time to actually start delivering on all the promises. So thank you for more attention, and we can see you at the booth if you guys are willing to discuss a little further. Thank you very much.
Thank you. Up next on the stage, we'll be talking to Roland Hackett, who's president of CMI Hydrogen. For the first time this year. Welcome.
Hello, everybody. It's a pleasure to be with you here today. I'd like to tell you a few words about hydrogen with the CMI, trying to find the button. First of all, CMI is a full energy player, not only for hydrogen, but full integrated solutions, starting with the solar, with the CSPs. We're building boilers in order to be able to generate full electricity 7 days 7, 24 hours a day through molten salts. We are also capable of doing maintenance of wind turbines. We are doing energy storage. I will get back to that, through electric batteries, and finally hydrogen solutions. This is very important because that offers you a combination of solutions in order to fight the climate change and accompany energy transition. Where is CMI in the value chain? Very simple. We start from the 12 to the 15 kilovolts and we go all the way to the distribution, whether it's mobility, industry, or power to gas. Classic schematic with production through electrolysis, purification, demisting, drying, compressing, storage, and distribution. The thing which we supply, which is a kind of difference, is that we're capable of smoothing the energy network. You know that one of the issues with renewable energies is that you have some ups and downs, and so it's not so easy to play with the frequencies. And what we have is that we offer a combined solution with batteries and the full electrolysis solution, so as to be able first to play and have the most stable power supply, and also to be able to have the electrolyzer to work in a as long as possible at the right capacity. We've been in the hydrogen world for over 25 years with more than 1,000 references around the world. We are based mainly in two locations, Western Europe, in France and Germany, and also in China, where we've got Chinese colleagues close to Shanghai in Suzhou. This is also where we've got our workshop. Different references: chemicals, glass making, aeronautics, steel making, power plants, silicon fabrication, any type of activities I believe we've been in. We've got a worldwide experience. We're present in more than 30 countries around the world, and we've got a very, very large World Cup capable of taking over the future needs in terms of hydrogen productions, with a novel capacity of over 350 megawatts. This is a modern workshop capable of providing references between 1 to 1,500 cubic meter an hour electrolyzers. Yesterday, on the same premises, I gave a speech about large-scale electrolyzers, where I presented a 1 gigawatt hydrogen plant, which was described by one of my colleagues, in order to be able to meet the challenges, the next challenges, which is to be able to green the steel industry, the ammonia industry, a number of chemical industries. For this, you need very large-scale electrolyzers. We had the pleasure to commission last year we are the first ones to commission the two largest single stack electrolyzers in the world, 2 times 5 megawatts in China. We've got a charge density of up to 0.4 amps per square centimeter, and we've got a pressure capacity of up to 50 bars. This is a very, very important point. Indeed, when you're looking at hydrogen solutions, you've got a combination of production, compressors, storage, and distribution. If you manage to get a good pressure outside of your electrolyzer, you will indeed gain a lot on your compressor station, thus minimizing both CapEx and OpEx. The sizing and optimizing the design of our H2 stations is extremely important. I just explained the importance of the output pressure of the electrolyzers. We have also built a model called Optimize in order to optimize the refueling in our stations, in order to have them very, very fast operations. within 3 minutes, compliance to CE regulations, high state of charge on a number of cars following one another, and in the end leading for an optimized CapEx and OpEx for our customers. I've got the pleasure to announce that a couple of weeks ago we sold the largest single stack electrolyzer in the world with a capacity of 7.5 megawatts capacity. Next year we will be able to sell a 10 megawatt capacity electrolyzer. And what I presented yesterday, for those who witnessed my speech, we're talking about 20 megawatt electrolyzers. That sounds a lot, but when you think about 1 gigawatt, this is 50 electrolyzers units, and if you think of adding a lot of stacks, this is the kind of size that make the 1 gigawatt power plant feasible. I'd like to present you a small project on which we're working on. It's a multi-purpose project. One of the difficulties for those who are in this business is that you need to be a jack of all trades and be able to design the full solution. Here what you have, it's at the Liège airport. That will be the 4th cargo airport in Europe. And the station will be capable of feeding the airport fleet, machinery, forklifts for the logistic platforms, but also the 4 shuttles that will circulate around the airport. We will be able to supply a bus line between the railway station and the airport, and also to be able to feed industries as well as private cars or taxis. This is the end of my speech. I thank you, and I will remain available, my team and I, at booth E73. Thank you very much.
Thank you. Mark Kammerer, Business Development Manager at Hydrogenics. Welcome. Name change. What happened to him? Woldemeyer.
He's probably too shy.
He's too shy. Okay, thank you.
Good afternoon, everybody. That seems to work. So my name is Roldemeyer, not Mark Kammerer. Apologies for that. I'm working with Hydrogenics now about 20 years. I will tell you a bit about our company. I will try to keep it short and pretend that this elevator is in a not too tall building. If you look at it, we have a big history. We are active for now more than 70 years. We started out building atmospheric alkaline electrolyzers. But about 25 years ago, we decided, well, actually, that kind of market is declining because historically large electrolyzers were very popular until the 1960s. And we got more into this idea of building integrated systems, which we deliver worldwide. So historically, 1,500 alkaline electrolyzers, atmospheric, big bulky stations were delivered all over the world for all kinds of industries. In the past 20-25 years, we delivered about 500 integrated alkaline systems, which were more compact, smaller. It's a picture we already used for quite a while. When I'm saying smaller, that is really the case. Typically, the market for the industrial market for electrolyzers has shrunken over the years. So standard sizes these days are in the range of 100, 200 normal cubic meters per hour. Sure, once in a while a bigger plant. Or if you would talk in kilowatts, 500 kilowatts, 1 megawatts, and that's about it. But then we have the whole revolution in the renewable energy world. So from all the lessons learned, all the history we had with our integrated systems, we decided to develop a newer technology, which is also supported by some other companies, and that is called PEM electrolysis. Now, PEM electrolysis is in itself a similar concept as alkaline electrolysis. The difference is that, well, it's more simple, at least on paper, because now you're feeding the electrolyzer only with water. An alkaline electrolyzer, you also need to add something to the water to make it work. A PEM electrolyzer only needs pure water. But there are challenges. A lot of the challenges are related to the stack. The stack itself has to be made out of pretty expensive materials. And nobody likes things to be expensive. So the big challenge is how to make it cheaper. The first tests started with a big stack, and it's actually, to the best of my knowledge, the biggest commercial stack in the world today. These are only 6 cells. The stack is a size which is about 1,500 square centimeter cell surface. And this was then the basis to build large plants. Large and hopefully simple and thus cost-effective plants. But we still like to integrate systems. Now, in the past, we managed to integrate up to 500, and we still do, by the way, 500 kilowatt of alkaline technologies in one 40-foot container. We can now integrate 5 megawatts of electrical power connection into 2 40-foot containers. One 40-foot container would be needed to take the place of all the AC/DC. The stacks itself, they're really not that big. We're looking at a stack the size of a refrigerator that could manage a power intake of 3 megawatts. The rectifier itself would take up 10 times as much space as the stack. And the stack is the heart of the system. Sure, you also need other elements to take out the hydrogen and the oxygen in a safe way to make sure they don't mix. You really don't want them to mix. To maintain the pressure, to maintain the temperature. But here you would have an impression of what a plant the size of a 100 megawatt would look like, which is a very compact footprint. If you would build a similar size plant with our alkaline technology, you would need at least 4 times as much land. The other advantage is efficiency. We see that new technology we can further reduce energy consumption per kilogram of hydrogen produced. So we have been involved already in about 10 projects featuring these large new stacks. It's all new for us. In the past 5-6 years, we've been working hard to make it all work, and we caught the attention of Air Liquide. Air Liquide is operating one of our plants a couple of years now in Denmark based on this technology, and that led them to the event that they invested in our company $20 million, and we signed up for a further joint technology development program. So we believe that the future is for large capacity PEM plants in the range of 50 megawatts plus. Thank you for your attention.
Thank you very much. So up next on the stage is Dr. Simon Bjørn, who's CTO at ITM Power. Microphone, please. Welcome, Simon.
Good afternoon. Thank you for the introduction. You've all done incredibly well to listen to so much talk of electrolyzers. I'm going to try and go through this relatively quickly. Let's make sure I get the right button. Nope. Nope. Which button do I press? Okay, cool. So ITM is a manufacturer of integrated PEM electrolyzer systems. You've heard a lot of detail already, but to try and cut that short, we build containerized systems largely with everything that you need to make the system work inside one package. They respond very quickly, inside 1 second, which is important for certain applications. We deliver the hydrogen at pressure between 20 and 50 bar, and we also have a very high efficiency. They have a small footprint. That's very important for a number of applications, particularly refueling, and particularly when looking at very large installations, footprint becomes very important, and we're operating at the megawatt scale. We've got 3 application areas that are of particular interest to us. The first is power to gas energy storage, and that involves taking renewable power, converting it into hydrogen, and injecting that directly into the gas grid, decarbonizing everything downstream. The second is hydrogen as clean fuel for vehicles. We operate a fleet of refueling stations in the UK, and we're also in the process of delivering a number of bus refueling stations, both in the UK and France. And the final application area is renewable hydrogen or industrial hydrogen. And this is particularly exciting where a lot of the very large-scale applications are beginning to emerge. And more on that in a minute. Okay, I've got this now. Very quick snapshot of where we are financially. We haven't been around for as long as you've heard. A number of the old alkaline companies have been here a long time. We're a lot newer than that, but we're growing very quickly. And to give you a snapshot between last financial year and this financial year, we've increased by about 50% in our revenue, and our deal pipeline is around 35 million at the moment. And we've got a strong position of cash. And you can see that's a pretty steep curve of revenue. So the backdrop, a common theme that you've heard already from the other speakers. Less than 10 years ago, our biggest product was 10 kilowatts in size. And now in 2019, we're in the process of delivering a 10 megawatt plant to Germany's largest refinery in partnership with Shell. So that's 1,000 times bigger, a huge technical drive necessary to be able to cover that distance, and something that we're particularly proud of. But it does give a sense of how the market is changing. More electrolyzers and bigger electrolyzers. So the project that we're doing with Shell is in the Rhineland refinery in Cologne. I'm losing track of which is the biggest electrolyzer in the world, but at the time this started, it was certainly the biggest PEM electrolyzer in the world. And to give a sense of scale, this one refinery uses 180,000 tons of hydrogen a year. So this very big electrolyzer at 10 megawatts represents about 1% of the hydrogen demand from that one refinery. But it does a number of things for them. It gives them a way of decarbonizing the hydrogen that they're generating that they need for desulfurization of fuels. And it also provides them with extra control across the refinery. They can load balance, smooth out the power consumption across the whole site, which helps them to manage how they purchase electricity. And they're also investigating future revenue streams, including export into the fuel market. Similar story as you've heard already. We are desperately trying to standardize. So we need to get our production volumes up, as you've heard from all of the previous speakers, and we also need to be able to manufacture larger systems. And to do that in a cost-effective way, you need to standardize. So the way we're doing that is developing standard modules. We have a 10 megawatt stack skid, which will qualify with Shell. And this is an example of a 100 megawatt layout using replication of those standard 10 megawatt skids. Very important to be able to do that. As soon as you can make the larger electrolyzer systems, you start to enjoy that virtuous circle of scale and cost, bringing cost further down. Production capacity, we are in the process of relocating to a larger facility. It will give us around 5 times the floor space that we've had before, and crucially, significantly more power, which is necessary for testing the products that we manufacture. At the moment, it's very difficult to describe scale because when you're manufacturing a very wide range of systems, it's hard to capture scale. So we've boiled this down into stack capacity. And at the moment, we have the capacity to make around 100 megawatts of stacks per year. Clearly, we're building other things as well as just stacks. And the new factory will give us the capability to get to 300 megawatts. And our aspirations beyond that into the 2020s is to be able to get up to 1 gigawatt in size. And those of you who know the industry recognize that's a very big challenge, but hopefully you've also picked up the story that this is the direction in which the industry is moving, and we need to be able to be ready to respond to that demand. So something on costs. I'm guessing this is going to be an inevitable set of questions later on. Cost too is a very difficult thing to describe. The unit that the industry tends to use is euros per kilowatt. And it depends on many things. The single most sensitive thing is, what do you call an electrolyser? What is the scope of supply? And for us, it's the stack, it's the balance of plant, all of the power equipment, the whole package. And as you build more electrolysers, the cost comes down through the economies of manufacture. As you build bigger electrolysers, the cost comes down. And also over time, you can include continuous improvement. Technology is developing at a very fast rate in the PEM space at the moment. And I think also you need to take account of the scale of equipment that we're tending to produce is getting bigger and bigger as time goes on. But I would also just highlight that the euros per kilowatt, the cost of buying the equipment, while it's obviously an important metric, it's not the only thing. It's important to consider value as well and what that electrolyser can do for you. More on that, I'm sure, in the questions later. So, trying to keep it very brief. Thank you very much for your attention, and I'll pass back to Brian. Thank you.
Thank you. You can hang on to the microphone and join us on stage, because I would like to invite all of our guests to come back up for the discussion. This is, I think, the most interesting part. Please join us on stage. This is the most interesting part. It's rare to have representatives in the same field cooperate in a debate about this technology. Somehow I want to introduce this. It's really difficult. If I go back 5 years, we had politicians and other big thinkers who said it's really simple. If we want to clean the environment, all we need to do is expand renewables, hook them up to electrolyzers. We've got salt caves to store things in, and everything is fine. The problem is you're competing with an extremely inexpensive hydrocarbon. Interestingly, at that point in time, I think it was Bjørn, you who said, right now, only 1% of the hydrogen being used is actually produced through electrolysis. And the big market is, of course, industrialized usages of hydrogen. I saw you at a presentation today, Hector, and someone said, you know, what we really have to do is approach the market. We have to decarbonize the industry that needs hydrogen, okay? So what we're really talking about, though, is steps towards the projects that we discussed today on stage. You were present for this notion of 40 gigawatts. And I think none of us are prepared to leap into that level of volume right now. It would be nice, wouldn't it? So how do we get there? Transitional phases, what is going to help us to decarbonize the industry? What are the steps that we take in order to well, start with the profitable decarbonization of the industry? I'll pass a microphone to anyone who has an idea.
Well, it's a big topic, but I'll kick it off. I think initially then the industry needs to see that the technology is real. So there has to be some deployment, there has to be some technology that people can go and look at and kick the tires. And you've heard a number of examples of projects that all of us are doing in that spirit. I think to be able to transition to the gigawatt scale that we've all begun to touch upon, there's perhaps a number of incentive schemes that are in the process of being refined at the moment that will perhaps help that very large jump to the next scale. And maybe it's too early to start talking about the Renewable Energy Directive, but that is one instrument that's being used in the EU to try and help facilitate large-scale electrolysis. And for me, it should incentivize electrolysers connected to renewable power, either directly or through a contractual arrangement, so that they can make green hydrogen, and that surely is the objective.
Well, it all sounded like a dream when I started talking about a 1 gigawatt plant yesterday. It sounded like a dream, like a vision. In fact, it's not so far, and we realize that it's a real need from our industries. We talk about steel, we talk about ammonia, and so we're there. it's not so easy to go from 1 megawatt electrolyzer to a 20 megawatt electrolyzer. And in order to do that, you need to anticipate what the market is going to do. You need to go step by step. Last year was a 5 megawatt commissioning. This year we're selling a 7.5 single stack megawatt. Next year a 10. So you need to get there. You need to anticipate. That's also in terms of workshops, because not all machines are capable of manufacturing and machining large stacks. To assemble those stacks is not so easy also. So it's an anticipation of things. And in order to do that, you need to have a clear plan and organize your workshop, organizing your R&D in order to meet those challenges of tomorrow.
So I started working with hydrogen about 10 years ago. During those 10 years, the levelized cost of electricity for solar has fallen 88% and wind 69%. Hey guys, that's the basis for our joint success. And there's a lot of people and companies out there that don't know that. Some of the companies of the 95 plus consumers of hydrogen today are probably paying more for the fossil hydrogen than they would if they invested in a new plant based on renewable energy. And I know probably all of you colleagues here are kind of tired of the educational job we have to do all the time with investors, with policymakers, with all these guys, but it's not over. We need to educate also these industries, the ammonia players, the refineries, steel companies, and it's not just educate them, it's just inform them and say, hey, this has fallen this much over the last couple of years. Maybe for your next investments, take that into account, and we need to help them make the business case with electrolyzers. We need to do the math for them and show, here it is, take a look at it. And I think we will have their interest.
There was an organization called European Hydrogen on stage, and he kept on screaming, do the math, do the math. So, but the notion here, I don't want to interrupt you, of course, but the notion is we've virtually reached fossil fuel parity in terms of cost. It's the problem of getting it to the market as fossil fuel parity, getting the applications also. All right. Hector?
Yeah, just quickly. I can go on for a long time, but I just want to say one thing. It's price. It's very simple. Can you match or you can't match the price offered by gray hydrogen? I think we have shown many examples here how you can match it. It's a matter of now, again, just showing it to the customer. This is it. You can pay $3 a kilogram with your fossil fuel, or you can use $3 a kilogram, or maybe less than $3 a kilogram with renewable. Take your pick. Now, of course, governments can help, and they will always have many incentives, especially here in Europe, hopefully eventually in America as well, push us hard. And the rest is there. We have reached now the point where we can actually compete at that level. 5 years ago, it was impossible. So it's price, nothing else.
Hans-Jörg?
Yes, well, I would say the train has left the stations as we speak. We are developing now tomorrow's hydrogen plants with the 100 megawatt plants. We are engineering now for northern France. We are really making a step forward, allowing us to produce hydrogen at a very competitive cost. Of course, we need to be able to supply all these units. So remember, our biggest unit is a 5 megawatt unit, but we are now also enlarging our production capacity. And then, of course, on the other hand, the electricity must be available. So, for instance, in Germany, we learned that the so-called renewable energy law with the EEG taxes virtually makes it impossible to produce hydrogen from renewable sources because you double actually the electricity price. So there, I think, from the lawmaker, there must be some initiative to adapt to the changing world.
Yes, I totally agree with you. The EEG in Germany, it really is artificial barrier for the hydrogen production for electrolysis. I mentioned this project in the north of Germany before, and actually we have to transport the hydrogen from the wind energy converter where the electrolysis plant is to a fueling station, not because we want to, because it's cheaper to have it on a truck than on the electricity grid. So what we need in the future is just a comparison of the price of transportation, electric energy, and stored the chemical energy. Yeah, and for the question regarding the production capacity, of course, what we need to learn now is to come from manufacturing stacks and electrolysis systems to fabricate them. So I'm pretty happy also Linde takes over. No, not what was it? It was Hequet taking over. So really a big company who has experience in mass production. In our case, it's MAN, and so we need all to learn. NEL is building really huge production capacities, pretty impressive. We are far away from that now, but if we look to just one industrial country, we have an electrolysis demand of 200 gigawatts. I think you have to scale up by orders of magnitude as well. So we need to learn that, and this is a key challenge, how to get the employees for that, and how to fabricate stacks and systems.
And there's two additional issues. One I think is interesting, it's energy security, and the other is jobs. On the level of energy security, is it smart to do fracking in the States, for example, or to use other sources of energy? In Germany, we import natural gas. A lot of countries will not put up with that very, very volatile situation. Where's our energy coming from? On the other hand, on the automotive, and I know the automotive, we don't want to make too much of it, but on the other hand, recently, that is literally on Sunday, there was an announcement for the Ministry of Transportation that they were going to pour €1 billion of your tax-paying money into expanding the electrical grid so that fueling up cars would be easier. Actually, Jülich did a study which showed that the infrastructure for recharging cars is cheap right now, but as the number of cars increases, the infrastructure for refueling hydrogen cars is less expensive. I know it's just a step, but what we're really trying to do is energy security issues, jobs. We can import batteries and forget about the jobs, or we can export technologies. So it's sort of another take on this. You're right about this is one of your issues. You're right about the automobile automobile not having much of a future in terms of cost. But where are we in terms of getting beyond this 1%? Where is the growth coming from right now? In order to expand, you need capital investments. Is there enough there to take the next step? Is it difficult to drum up capital?
I think there are several groups out there today investing in specifically this kind of goals when we're trying to reduce CO2 emissions by hundreds of tons, and there's several groups out there already doing this. Mm-hmm. So I think the capital is there. The point is you have to show that that working capital will actually produce your molecule of hydrogen at a competitive cost with what's available. Mm-hmm. Once you do that, you don't have to look for the market. The market's already there. You just have to go and offer it to these industrial partners. We've been talking about steel, ammonia, and many others. Those take a tremendous amount, much greater than what all of us together can do. It's just a matter of, can we do it at a price that's attractive to them? Mm-hmm. If we can, then of course, capital is available. Mm-hmm. So it's, to me, it's the same, as simple as always. It's, can you do it cheap enough? If we can, and I think we can just go and offer it now. Challenging is, how do you speed up your scale up? Even with having the right capital, it's going to take some time, but by far, there's no question that you don't have the grid available today to just do everything electric, all your cars electric. I mean, the fuel cell electric vehicle is going to be an electric car at the end of the day, but it's just not feasible from an infrastructure standpoint. I think GM did a study not too long ago where the grid had to be upgraded many times over just in the US. So we have a different challenge in hand, and that's not the answer.
I also think there's a certain inevitability about this. You know, it just isn't feasible to run the transport network via electricity. And we see already the large vehicles, the physics tells you can't use just batteries. You have to use hydrogen. And that one of the great things that an electrolyzer does for you is it allows you to control when power is exported from the electricity network, and then it separates that moment from the refueling event. So if we all have plug-in electric cars and we plug them all in at the same time, that gives the grid one hell of a problem. And electric cars are part of the solution, but you need to use hydrogen to cover that distance and to cover that range. And to give a bit of an example, in the UK, the electricity grid is around 300 terawatt hours a year, whereas we use about 700 terawatt hours a year in fuel, and about 900 terawatt hours a year in terms of natural gas, which we use predominantly for heating our homes. So if we're going to decarbonize all of these things at such scale, what other technologies are there? It has to be hydrogen. And I think the pennies dropping, the markets are developing, the pilot projects are happening, and I really do think that we're seeing the electrolyzer industry responding to that and saying, look, we are developing the capability and the means to match that demand. So it is happening, but the sort of repeating yourself education bit is we say this every year, there's an inevitability about hydrogen, and that's why we're all here. We all kind of believe it. It's about making it happen, and that is the crucial next step.
So what we need now, the whole industry, is basically bold action, because the conditions around the entire renewable hydrogen industry are ready. The vehicles are ready, the fuel cells are ready, all of that stuff is ready. What we need is bold action from the car manufacturers, from the different energy companies, from us also, to make the next step. Is it a chicken or an egg? Who invests first? Well, we all have to invest. We all have to make that. It's not even a leap of faith anymore. We have all these reports we're talking about. There's the evidence, but we need to go out there and basically shout it to the markets. And what's interesting to see is that it is these companies that go out there and make some bold action. That's where the money is flowing from the investors. Who's moving the hydrogen transport industry of the world now? Basically, it's a startup company from the US that will probably lead to the biggest orders and deployments of fuel cells and hydrogen stations and electrolyzers for the coming 3 to 5 years at least, maybe even beyond. So these other companies out there, they need a kick in the shins to wake up and say, hey, now is time to move.
It really is a question of message, because I can see the point, decarbonizing the industry, because the industrial use of hydrogen, this is the massive volume we're talking about. You know something wrong with that argument? It's financially viable, it's not pretty. It doesn't sell. Unless you make the point of how much energy we're talking about, it really is a difficult argument to make. And even the fundamentals of using natural gas, it's not the worst hydrocarbon in the world. I come from Canada. We have a lot worse there. So it really is interesting. What is the argument that will make people realize that long term there is no way around hydrogen as an energy carrier?
Well, I believe it's a combination of things. Typically, when you go for hydrogen projects, you've got 3 points: the capex, price of electricity, and unfortunately subsidies. I say unfortunately because it cannot go on and on and on. And at one point, this system will have to stop. Mm-hmm. Even if we beg for money, we all beg for money because we need to kick that system off. Mm-hmm. That will have to stop, because, like one of the colleagues said, the true thing will be when the green hydrogen will meet the price of fossil as it stands. And when green hydrogen will be more competitive than fossil, at that point, I would say we can claim a victory. Until then, there will be no victory, and we will have to keep fighting. Everybody is not equal in that battle. Of course, you've got regions of the world which are much better. You're talking about Australia, talking about Chile, talking about the North Sea with wind. So either you have wind, either you have sun, and then you can have curtailment, and then you can use that very cheap, even negative price of electricity in order to build up some structures and to build up the power. But for sure, we talked about the industry. The only vector for this is price. If you come with a higher price, no way. Unless governments around the world decide, like they do for cities, that, okay, it's enough of CO2, a lot of pollution, health issues, People can't take it anymore. People demonstrating in the streets, younger people. And at that point, this is what will make things change. So I think it's a combination of things, but clearly that will be a long battle. And first, everybody concentrates on captive fleets, captive customers, because we know this is where that stands. And the more constraints and the more help in the meantime will help all of us.
Yes, I agree with you, and I can see from all the discussions here that electrolysis production is kind of grown up, because what we are talking about is business cases, how to scale up mass production, reduce our prices, and how to be competitive in the future and make a lot of money. But I think the main goal behind all of this we haven't talked about today, and this is a CO2 reduction, right? We need to scale up, and there is not only the driver of making money behind it, the driver behind all this is to reduce the CO2 emission on the world and to give us a future. If we don't succeed with this technology, we are all fucked up. It is like that. There's no way around. There is no other long-term energy storage but hydrogen production. And so we need to make this happen. We need regulations that actually give this technology a chance, like a fair CO2 price. I'm not talking about subsidies. This will kill all this stuff. We need to have a business situation. This can come to a CO2 price, emission certificates. And if they are there, we are competitive at the moment. And in the future, we'll be even cheaper and gain a lot of money. But we have to reduce our CO2 emission, and this goes through electrolysis.
I should add that we open the floor now to questions from the audience. I find it amazing that if we go back in time, all we would be talking about would be CO2 emissions. There's a point at which that argument seems idealistic. Now it becomes a possibility. But you're very right. By the way, not just CO2 in Berlin. You pay less rent if you live close to streets, because the incidence of cancers there from what the Germans call Feinstaub, fine particle diesel emissions, it is an issue. It affects our health, and it is very important. It's not always an easy sell, because they're talking about phasing out diesels, for example, or drosseling the traffic, or increasing public transportation. They're all dancing around that issue. Are there questions from the audience? Mm-hmm.
So Brian Pivover from Menrel. There's really two things that I'm interested in you guys talking about. The first is there's a valley of death in terms of the investment that's taken. How do you guys feel about what China might do in this space, and what they've done in other fields like solar and battery? And how do you protect yourselves and position yourselves in the global marketplace for such threats? And then I think that there's these aspects of like local air quality that are critical for this. And one of my concerns is that I agree that hydrogen's inevitable. And I agree that the longer we take to get to that inevitability, the higher cost the planet pays to get there. And what we need to do is be able to quantify the urgency and sell the urgency of what we're doing to get to these scales, because I'm actually suspect about how much fossil fuel we have and how cheap it is, and it's our job to make it as cost competitive as possible, but I don't think that we should be tied to the fact that it has to be parity, because right now society is not paying for the social costs of the energy system we leave by any individual, and those social costs are important in terms of the value proposition, what hydrogen brings to the energy system, and how you educate the public and bring out those factors so that they're considered in making these choices. I believe that it's things like renewable portfolio standards, zero emission vehicles, and then the financial validity of green processes in industry that don't exist today that are going to be required at some level to do this. So those are just some further talking points maybe.
It's a really nice point. I live downtown in a city, not a very big one, but there is a high value on electric vehicles. Just when I'm standing at the bus transport station and the old bus comes by, it is really noisy. The exhaust gases, they are smelly. And 10 years from now, 15 years from now, mostly all of them will be electric. So there's no noise, no emission, and this gives a high value for the society inside the cities. And yeah, of course, this has a certain price. We won't pay for it, but it's life becomes better in the cities for sure. And the point of the Chinese market, yeah, it is huge, and I'm pretty sure that they will get a huge piece of the cake. But in my opinion, the cake is that big. We don't need to worry about that in the next decades.
Thanks, Brian. I actually think that these groups that we're talking about to bring capital into these companies, some of them have very, very noble actual goals, and they are doing some lobbying also. Without the lobbying, you won't get all these laws to change. And we've seen the laws changing already in Netherlands and in many Nordic countries, which is fantastic. I wish we had that kind of political will in the US, which we yet don't have. But I know that those groups are lobbying and lobbying hard, and eventually we will get there. We're probably going to be falling behind. We're already behind Europe. I think we were going to catch up, and we need to catch up. I read yesterday an article about China, what they're doing, and how much money they're pouring into this side of the equation. Certainly, China is very interested. They have a huge problem with pollution. We all know it. We'll have been there. We'll have survived being there. But in the end, they already made that decision. They're switching over, and they don't have enough capacity, bringing all the renewables, plus coal, plus everything else. So they will be a big driver, of course, in cost. And for us, the driving force is actually starts with legislation, because those guys who have made the conscious decision to invest big dollars in this, they first go there, switch the legislation, and they will already have the product available to service the market. So it's a little bit harsh, but all those things have to converge at the same time. I don't see how we can just. I earlier said it has to make sense on the dollar sign, or it has to make sense on the euro sign of the equation. The problem is we have to have also a little bit of coercion from government and legislative bodies to actually make it happen. So I believe that a lot of these groups are starting to do this kind of lobbying, this very heavy lifting effort. And what we can do, other than calling our congressman or anything else, it's actually bringing that technology available at the right price tag, with a fast reaction time that we can actually come in and rush in.
And it kind of seems crazy, doesn't it, that you can generate your own fuel from renewable power. You can refuel a car and have no carbon footprint in any of that whatsoever, and the cost per mile is about what you'd pay for diesel. You know, and the fact that we have to sort of say, you know, make that linkage between all of the health issues and so on that goes alongside air quality is it's amazing that has to be done. I think we have to keep plugging away. We've got to keep lobbying. We're starting to see movement in certain cities that are banning diesel engines, and they're starting with toxicity charges and things like that. But I think the most emotive thing is to link it directly to health. And you know, some of this isn't always that. Some of the technology isn't that sexy. You know, we've got to try and do a better job of getting it across in a palatable way that reaches the right people. But I mean, I agree with you. You're banging your head against a brick wall. You know, this is the right thing to do, and we need to do it. You know.
In terms of the public and incentives and all of that, I mean, yes, of course, that's extremely important, and it's a slow process, and it takes a lot of concerted effort. We're getting a lot of help from other industries, also the renewable industry, battery electric vehicles, etc., all of those. What I think we can do as an industry to really get hydrogen out there, get it on the map, and get it down to the cost it needs to, is to make sure 1 or 2 or 3 of these big projects succeed, because we're coming from such a small scale that the total electrolyzer market today is probably less than 100 megawatts. That's the total market. And if you can get one ammonia plant to go green, that's 20 times the total market. It's a complete game changer for the entire industry, which will help take the prices down. It will get manufacturing up, which will then help position hydrogen as an alternative everywhere else. So it's not crazy massive investments needed to actually get to that point, to make sure those projects succeed. And I think that, at least from our perspective, is one of our focus areas now, is to make sure some of the really, really huge projects are successful and carried through, because then there will be lots of benefits piggybacking off of that.
Any other questions from the audience? One point about China, just so we understand the industry, because basically we're still also waiting for applications. That is, had there been a strategic decision to decarbonize traffic in cities, had there been a decision to mass manufacture cars that run on hydrogen, we would have had economies of scale also for the fuel cells, which we haven't had, except in China. And what they do, they have a methanol grid. So there's a few manufacturers here. They do reformers and PEM cell-driven automotive applications. Why is that important? It's because in 2018, the number of fuel cells sold to China is equivalent to the number of fuel cells sold to all other countries in the world since the beginning of the manufacturing of fuel cells. That was 1 year. So it is booming. Economies of scale are increasing. We need to have that argument here, though. So it's kind of interesting. I get it. What you just said. You know, if you get one large consumer on an industrial level to shift his supply from reformed natural gas, for example, to electrolysis, you have a quantum leap in your manufacturing capacity. If they decide to do that, how easy is it to ramp up your production? How ready are we to?
Well, when we think about the issue there, if you look at the consumer, okay, whether it wants to buy a Mirai or Nexo, it's like 80,000 euros, double the price of a regular car, as we know it. Very few stations around, so why would you invest into such a car? I mean, they're working well. I mean, I had interviews with cab drivers in Paris. I mean, they're quite happy with their car. So it's not a technical issue. It's a money issue. If you're talking about a steel plant, and we talk to them a lot because that's my background, and same thing, I say, well, I buy my hydrogen 1.5 or 2 euros a kilo of hydrogen. So why would I now pay for 4, 5, 6? So it's all about money, and this is why I think this is exactly what my colleague said. We need to massify and to find some good examples where you can make it happen. And before, people were scattering solutions around the world. Now it's more, let's take a city and make it happen. And this is exactly what China is doing. They selected, I believe, 8 cities, which are so-called hydrogen cities, where they will make it happen with all the hydrogen problematics. And the more, the better. Let's not be afraid of China or other parts of the world. The more cars will be hydrogen cars, the prices will go down, and this is how we will get a chance to have a better world tomorrow.
Well, I can only support that. China is not a threat, it's an opportunity to develop better products. And when it comes to capacity of production, I think we are all prepared to ramp up capacity. We are coming from a situation where we are manufacturing electrolyzers, and now we can easily ramp up production and go to mass production and use the economy of scale to reduce the cost.
Questions from the audience?
Sorry, just one question. We are talking a lot about. We're talking a lot about scaling up to the gigawatt and more, and like changing the entire energy world and everything. When we talk about PEM technology, we have the issue of rare earth materials, and now there's like alkaline and PEM. They are both like the strong technology going forward. As far as you guys know, will it be possible to go with PEM technologies to those sizes, or the material at some point will start to become an issue?
Can you repeat the question, please? I think I heard something about scale in PEM.
Well, the question really is about the precious metals in the PEM systems. Among other things, the cost factors there. Is there enough around to scale up in production? Are we going to run out of the materials used in PEM electrolyzers?
So I love that kind of question because it's so focused on fuel cell side, and they always think about how fuel cells have to decrease your platinum and other precious metals in there. Well, what has happened in the last few years, last 6 years, we have dropped about 20 times the loading of precious metals into our membrane. And more importantly, the amount of hydrogen that gets processed by that kilogram of platinum that we put into it has increased tremendously. I mean, we're actually at a point where we can almost eliminate completely the platinated groups and still make membrane that would work for PEM. So there are several different, if you start looking at all the research being done today by my company and maybe other companies as well, is we're focusing on how can we replace those, not only bring them down to close to zero, but replace them with other materials that are just as good. The problem is we don't have to be just as good, we have to be actually better than what we're doing today. So we have proven already in some cases with specialized catalysts that we can get there. Now the question is it cheaper to do it that way today? No, it's not. The moment that we have to switch later on, as platinated groups become a problem, we can always switch. But let's not lose focus on one thing. When you look at a fuel cell and you see the content of platinum into the fuel cell versus in the electrolyzer, when you see how much of that goes to the bottom line of the cost of hydrogen, it's really insignificant on the electrolyzer side. It's not so much on the fuel cell side. On the high precious metal groups, because we keep on decreasing that and eventually replacing it, it's not something that scares me. I'll be more scared about running out of iridium, maybe lithium, other metals that are not necessarily the platinated groups. And in the case of lithium, just the fact that you have to mine it, you have to destroy the earth, and you have to put all this carbon into the atmosphere just to get the lithium in the first place, then stick it into a car, use it for a few years, and then have to recycle that. That's expensive, and it's not viable, because if you wanted to replace today all your cars to electric, every single one of them batteries, it would take us 360 years to mine it. So do we have 360 years to wait? We don't. So it's a fallacy, and you have to really look at the supply chain of both sides. And in my case, it's very clear. Hydrogen has a much better outlook in that respect than the battery. So no, I'm not afraid of it.
Frank?
Yeah, I think there's a slight danger for iridium shortage in the future. If we scale up the production capacity by orders of magnitude, then it can come to a shortage. But at this point, when the prices go up, I mean, there will be more mining. There is enough iridium in the ground, so that should be just the case for a couple of months or years until companies decide, okay, there's a good price, let's mine more, and then we have enough. And yeah, I totally agree. Iridium costs or platinum costs are really just a fraction of hydrogen production. It's not cost determining; it's electricity price.
Well, there's so much else we could continue to talk about. I always worry about the frustration level of the colleagues here, because it's, 90 minutes that we've been standing and talking in total, including the presentation. But this is one of the most interesting formats for me. It's sort of the crowning achievement of your industry, that you've occupied so much space and you've become the center of the discussion. It used to be the PEM cell. Now everyone knows it's electrolysis, and people look to you people to make the environment green and to clean up the traffic. It's a phenomenal achievement. You're recognized as having that role potentially in the future. So it's quite a responsibility, and it must be quite an honor to be in that position. That's how you are being perceived. It's been a pleasure to talk to you this year. Dr. Hans-Jörg Fell, CTO of HydrogenPro, thank you for showing up. I hope to see you back here next year. Bjørn Simonsen, VP Market Development, PR at Nel Hydrogen. Bjørn, thank you again. Frank Allebrod, who's head of R&D at HTech Systems. I should be announcing their booths, by the way, as I go through these numbers, so let me go back. Hans-Jörg Fell is HydrogenPro E46. Bjørn Simonsen, Nel Hydrogen is B60. Frank Allebrod, head of R&D at HTech Systems, is B52. Hector Maza, vice president of Kammerer ELX, is C47. Roland Hackett, president of CMI Hydrogen, you're E73. And Raoul, he disappeared. But I'll give the booth nevertheless. Hydrogenics is E59, and Dr. Simon Burns, CTO of ITM Power, B68, right across there. Thank you so much for your patience and your contribution. Where would we be without you? Thank you.